Today we're going to take a quick look on how you can make your own LED wall art. Let's get started. For this project, we're going to use a free software called Inkscape to create the base design, and then we're going to use Tinkercad to create our STL files. The 3D parts we're going to print in two separate pieces. The surface or the top piece we're going to print in black PLA. The walls or the sides we're going to print that in clear PLA. For the electronics we're going to be using the BTF lighting, high density individually addressable LED strips. To control that we're going to be using the Keys ESP8266 development board with Wi-Fi, and we're going to install the Wled software on it. Now this Wled software will allow us to control our art from the phone or a computer and comes pre-programmed with many different patterns and effects for us. Now you can follow along with me, or you can just download the STL directly from my Thingiverse page. But to make this, first I started by creating a spiral. It's a standard object in there, and I'm going to cut and paste a second spiral directly on top of it. And we're going to do this because we need two different images. We need one for the flat surface that's going to be solid and can be extruded up, and then we're going to need one that's just the walls that can be extruded up with a center infill piece. And you'll see that in a couple minutes and it'll make more sense. But what I just did here is just copied and pasted a spiral, made one a little bit bigger, and I created a little line to close that gap. Then I'm going to export this directly to a PNG. Now for the second piece, all I need to do is grab the bucket and fill in the inner piece, and that's going to give us our solid piece. And we're going to go ahead and export that to a PNG as well. Now normally we would have exported the SVG out of Inkscape and directly imported that into Tinkercad here. But the problem is, for some reason, the SVG file does not play nice with Tinkercad. So what we're going to do is we're going to go to a website and we're going to convert the PNG that we created to an SVG and import that into Tinkercad. And that's going to give us the nice 3D model that we're looking for. So to do this, we're going to use this website that I found called convertio.co. And this is going to take the PNG and export us an SVG that Tinkercad can read. So go ahead and take a couple seconds and run this through this processor here and get those SVG files. Now that we've imported the SVG directly into Tinkercad, and all we did is use this little import right here and brought it right in, you can see now that we have a much better 3D model. So all we're going to do is extrude this up just a little bit. I made it 18. I kind of wished I'd have made it about 23 millimeters. So you may want to adjust yours just depending on how you want to store your electronics. I'm storing my electronics down near the power cord, but if you want to actually embed it inside the art, you may want to make these walls just a little bit taller. So let's go ahead and make that 23, and all we need to do now is export this STL and print it. We'll do the same for the solid piece. For the top piece, we're only going to bring the extrusion up about 3 to 4 millimeters, depending on how thick you want the piece. Next, I 3D print the top piece and the side pieces separately, and I do this using PLA. Now we need to get the software on the microcontroller. So all I needed to do was connect this to my computer. I did have to install this CP21X Windows driver. I'm not sure everybody's going to have to do that, but I will link to that in the description down below. And then we're going to use this ESP Home Flasher, which is this software here. I've already flashed my board, so I'm not going to go ahead and do it again. But all you have to do is connect your board, and it will show up here as a COM port. Browse to this binary file and click Flash ESP. It should take about 45 seconds, and you'll get a blue light blinking, and it will be good to go. Now this LED strip should be pretty straightforward to connect. It came with 3 wires, a red wire, a green wire, and a white wire. So the red is going to be our power. It's going to connect to this pin right here. Our white wire is going to be our ground. It's going to connect to this pin right here. And the green is going to connect to this pin right here, which is D4. And that's it. To configure the controller to work for your network, what you're first going to do is open up your phone or use your computer that has a wireless adapter. And it's going to show up as a wireless AP. Just connect to that, and by default, it's going to open up a configuration screen that looks a bit like this. Fill out the properties for your network, hit save, and you're going to be good to go. The next thing you're going to want to do is install the Android app or the iOS app on your phone called Wled. You can get it from the Play Store there, and I'll link it down below. And this will let you control it directly from your phone and not have to come back to the computer anytime you want to modify the effects or colors or any of the configuration for the controller itself. Now that that's done, I primed, sanded, and painted the topmost piece, get it a little glossy and shiny, and got it exactly the way I wanted it. And finally, I took the sticky tape off the back of the LED strip and stuck it directly to the inside walls of the clear printed part. And as you can see, it came out exactly how I wanted it. This is the perfect piece of art for my office. I'd like to see what else you guys can come up with too, so leave some comments down below, send me some pictures. I'd really like to see what different effects you like to do and what kind of different designs you can come up with for your plastic parts, because you don't have to use a spiral. You can make this look any way you want. Thanks for watching. Questions and comments can be left in the box below, and if you like what I'm doing, please like, subscribe, and share this video with your friends. Until next time.